Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about the alkylation of terminal alkynes. Here are the basics. First, this reaction converts unsubstituted alkynes to substituted alkynes. It requires extremely strong bases and an electrophile to do the reaction. And three, it can occur twice if the starting material, abbreviated here as SM, is acetylene. So let's jump into the mechanism. If we look at an example of a terminal alkyne, this means we have one end of the alkyne that's unsubstituted and one side that is substituted. Since we're talking about requiring a strong base, the base's role is to deprotonate the relatively acidic hydrogen. The pKa of this hydrogen is about 20, which is equivalent to that of acetone. Okay. Now, in this actual reaction, this example of a substituted acetylene, 1-propyne, this can undergo a reaction with sodium amide, NaNH2, followed by something like methyl iodide, a classic electrophile. So sodium amide deprotonates the hydrogen, and then that resulting acetylene anion, that resulting acetylide anion will attack the methyl iodide in an SN2 fashion to alkylate, that is, put an alkyl group on this alkyne. So let's look at this mechanism. In the first step, sodium amide deprotonates this relatively acidic hydrogen to make the acetylide anion. Now this acetylide anion will attack the methyl iodide in an SN2 fashion to kick out the iodide. This forms the product. Okay, now this reaction can happen twice if you start with acetylene. So acetylene, remember, is just 2 carbons that are triply bonded. And then this can go through 2 rounds of deprotonation, alkylation, deprotonation, alkylation. You could have these reaction conditions. And it's very important to have these separated. You first add the sodium amide, you create the acetylide anion, then you alkylate the first time. Then you add sodium amide again, followed by a final step of methyl iodide again. This gives you the following alkyne with 2 methyl groups, one added to either side of the alkyne. Okay, and the mechanism follows exactly as I just showed above. So questions you might ask in office hour: 1, why do you need such a strong base? 2, are there other electrophiles that can be used? 3, what kind of solvents promote this reaction? Well, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.